Let's try to compute derivative of, so this graph here is sine x graph, and let's try to compute the derivative of this, or sketch the graph of the derivative, right? It will not be accurate, but at least it will be. So, so note that the derivative here is going to be, derivative is the slope of the tangent line. So derivative here is going to be the slope, the tangent line is horizontal. So the slope of the tangent line is 0. Similarly, here the slope of the tangent line is 0. Similarly, here the slope of the tangent line is 0. And here also the slope of tangent line is 0. So since I'm drawing the derivative graph here, let me mark these points. So here the slope of the tangent line is 0. Here the slope of the tangent line is 0. Here as well the slope of the tangent line is 0. And here as well the slope of the tangent line is 0. Okay. So now note that if the function is increasing, the derivative is positive. So for this part, the function is increasing, so the derivative is positive, and then the derivative has to become equal to 0 here, right? So the function is increasing and the derivative is what? Derivative is positive. So the derivative is positive, but the function is increasing. However, the slope of the tangent line, basically you see it, the slope of the tangent line is slowly becoming 0. So here the slope of the tangent line becomes 0. After that, the function is decreasing, so the derivative is negative. So the derivative is negative. At some point here, actually at this point, we'll see later why, the function will take a turn and go back up so that the derivative can become 0 at this point. After that, the same thing will happen. The function is increasing, so the derivative is positive. At this point, again, the derivative is still positive, but the derivative will start decreasing, so on and so forth. Okay, and so this is how the graph will look like. Now, does it remind you of some graph? What graph does it remind you? Exactly. So f prime x reminds us of cos x graph. So let's see that this is indeed the case. Okay. So derivative of sine x is cosine x. So these are the derivatives we must know. Derivative of cosine x is minus sine x. Derivative of tan x is secant square x. Derivative of cosecant x is minus cosecant x cot x. Derivative of secant x is secant x tan x. Derivative of cot or cotangent x is minus cosecant square x. So we should be able to prove all of these. So we'll start with the first proof, namely derivative of sine x is equal to cos x. So let's embark on that. Again, this does not follow from the previous laws of derivative or previous formulas of derivative we have derived. So we'll have to start from the first principles or from the definition. So f prime x is limit as h goes to 0, f of x plus h minus f of x over h. So you're calling here your f of x as sine x. So this is going to be limit as h goes to 0, sine of x plus h minus sine x over h. Now this is going to be limit as h goes to 0, Now there is a formula for sine A plus B. Sine A plus B is what? Sine A plus B is sine A cos B plus cosine A sine B. So we get, in this case, we get sine X cos H plus cos X times sine H minus sine X, the whole divided by X. Now, this is going to be limit as H goes to 0. Note that we discussed about this, that sine H over H, limit as H goes to 0 is 1. Yeah. So this limit you are supposed to know. We'll prove it later on in more details. The other one you need to know is limit as H goes to 0, cosine of H minus 1 over H equals to 0. So we can derive this. We can derive the second one from the first one. We'll see that in a minute. But what we'll do is the following. So we will arrange. So we can take this part divided by this, and the rest from the other two we'll take sine X common and organize them. So let's see, what do we get? So we can take sine X common from the other one. We get cos H minus 1 divided by H. We have cos X times sine H divided by H. Yeah, you're dividing H throughout, so I will divide only to this part. I mean, of course, the reason is that I have these limits which I'm going to use. So limit of H goes to 0 of this guy is 0, so you get 0. And here in the second one, you can take, so you can reorganize this as follows. So sine X has no H in it, so the limit, the constant, it is constant with respect to H, so it will come out of the limit. And here you can take cos X common. You can take limit as H goes to 0 of sine H over H. And this limit is 1, so you get sine X times 0 plus cos X times 1. So it is cos X. All right, so we have shown that derivative of sine X, if f of X is sine X, then f prime X is cos X, or we can write it as derivative of sine X is equal to cosine X. Now, similarly, you can prove by the similar argument, similarly, you can prove that derivative of cos X is negative of sine X. Okay. Now, these are the two results, very important results. So limit as theta goes to 0 of sine theta over theta is 1. And second one, cos theta minus theta over theta, limit of theta goes to 0 is 0. So this will prove later when we use L'Hopital's rule. I will also show you graphically what does this means, how do we get to 1. But now I'm going to prove 2 using 1. All right, so let's prove that. So limit as theta goes to 0, cos theta. So now we want to write down cos theta in terms of sine theta. So how will we do that? So we know that. So how do I convert this into cos theta? So I have cos theta minus 1 and I want to convert it into sine theta. Any ideas on how to go about it? Well, one way is to use double angle formula. Okay, so we can always use double angle formula to work it out. Another way is to multiply by, basically, we can multiply it by top and bottom by cos theta plus 1, because we know cos square theta minus 1 is going to be minus sine square theta. Yeah, so we can exploit that. So we are going to exploit the first one to solve it. So I'm going to multiply top and bottom by, so this limit, let this limit be L. So L is equal to multiply top and bottom by, or numerator or denominator, that's the right way to say, cos theta plus 1, cos theta plus 1. So when you do that, you get limit as theta goes to 0, cos theta, so this is going to be cos square theta minus 1 upon theta times cos theta plus 1. Right? A minus b times a plus b is a square minus b square. Now we have, this is going to be limit as theta goes to 0 minus sine square theta divided by theta times cos theta plus 1. Now I'm going to split it. So this is going to be limit as theta goes to 0 sine theta over theta multiplied by whatever remains, I'll keep it on this side. So sine theta divided by cos theta plus 1. So limit of a b or f times g is limit f times limit g, provided both these limits exist. Now, does this limit exist? Yes, it does. This limit is what? 1. What about this limit? As theta goes to 0 of this guy is what? So let's see. When you put theta equals to 0, you get sine 0 is 0, 0 upon 2. So this limit also exists. So I can break it into two parts. So this is going to be limit as theta goes to 0 sine theta over theta times limit as theta goes to 0 of minus sine theta over cos theta plus 1. Now this is going to be 1. This is going to be 0. So 1 times 0 is 0. So you have proved that what? That limit as theta goes to 0, cos theta minus 1 over theta is 0. So this is a legit, so this usage was legit because we have proved that. Yeah. Now let's prove the following. So what is derivative of tan theta or tan x, because we are differentiating with respect to x? So rather, let me ask the following. Show that derivative of tan x is secant square x. Yeah. And you can use using derivative of sine x, which we already found out to be cosine x, and derivative of cosine x is minus sine x, which you can prove later as a homework, or you can wait until chain rule to see how we can derive derivative of cosine x from sine x. Okay. So let's do this problem. So d by dx of tan x is going to be derivative of, now tan x is sine x over cos x. So now using quotient rule, what do I get? I get cos x squared, cos x times derivative of sine x minus sine x times derivative of cos x. So what do we get? We get this is equal to cos x times cos x, because derivative of sine x is cos x, minus sine x times derivative of cos x is minus sine x divided by cos x, which is same as cos square x. This is going to be cos square x plus sine square x divided by cos square x. Now, cos square x plus sine square x is 1 for any x. So we get this is equal to 1 upon cos square x, and 1 upon cos square x is secant square x. So this is how. So let's differentiate dy by dA. It's a y equals to 1 plus tan x divided by x minus cot x. So how do we go about it? So take dy by dx, and you'll have to use quotient rule. So x minus cot x the whole square times x minus cot x times d by dx of 1 plus tan x minus 1 plus tan x times d by dx of cot x. Now let's employ the derivative. So x minus cot x will remain as it is. There's no derivative taken there. Derivative of 1 plus tan x. So derivative of 1 is 0. Derivative of tan x is secant square x. Then you get minus 1 plus tan x. And derivative of cot x is, or cotangent x is minus cosecant square x. X minus cot x squared. So either you can leave your answer at this, or if you want, you can simplify it further. It's up to you. Okay. Unless you are specifically asked in the exam to simplify it, you can leave it that. Okay. Now, next problem. Find the points on the curve where y equals to cos x divided by 2 plus sine x, at which the tangent is horizontal. So you want to find out where, what? We want to find out the points on the curve. So points on the curve look like what? Points on the curve look like f x naught, f of x naught, right? This is how the points on the curve look like, because points on the curve will have both values, x values and y values. And you want the tangent line to be horizontal, which means what? The derivative is 0, because derivative is a slope of tangent line. So we want with f of x prime equals to 0. So once you set the objective, now we can work on it. Okay. So let's work on this. So what do we get? So dy by dx. In this case, again, you have to use the quotient rule. So 2 plus sine x the whole square times 2 plus sine x times derivative of cos x minus cos x times derivative of 2 plus sine x. Now let's take the derivative. So we get what? This is going to be 2 plus sine x times derivative of cos x, which is minus sine x, minus cos x times derivative of sine x, which is cos x. So again, another cos x divided by 2 plus sine x the whole square. Now, since we want to find out where dy by dx is 0, it's meaningful to simplify this. So we need to simplify this. So this becomes minus 2 sine x. So I get what? I get minus sine square x minus cos square x, right? So minus sine square. So I'll take minus sine square x minus cos square x. So I'll take the minus sign out. I'll have sine square x minus cos square x. So sine square x plus cos square x is 1. So we get 2 minus 2 sine x minus 1 over 2 plus what? 2 plus sine x the whole square. Now you are looking for when is dy by dx. So dy by dx equals to 0 implies, now see, the denominator is 2 plus sine x. The lowest sine x can go is minus 1. So the lowest it can go is 2 minus 1, which is 1. So the denominator never becomes 0. right? So this is always positive and non-zero. So the zero should come. So to find the zeros, we have to just look at when the numerator becomes zero. Otherwise, we'll have to work a bit more. But otherwise, if the denominator also became zero, then we have to look at, oh, when the both of them are zero and exclude those points. When both means numerator and denominator both are zero. But since the denominator is non-zero, this makes life easier here. So we have numerator is zero. So the derivative is zero when the numerator is zero. This gives me x sine x equals to minus 1/2. Now note, so what values of x gives you sine x equals to minus 1/2? So you get x equals to pi by 6 with a minus sign. Okay, so note the following. So sine, if you look at sine, sine is the y value. So when is so at pi by 6, at pi by 6, the value is, the y value is what? Is half, is half, right? So here, sine here is half. Now you can get the same value. So sine is the x value, right? So sine is the y value. So you can get the same value here, but with a negative sign. So that happens when sine is, this is minus pi by 6. Another place where you can get the sine value as minus half is this point here, which is pi by 6 plus pi, right? So pi by 6 plus pi, which is going to be what? Pi by 6 plus pi, which is going to be 7 pi by 6. Now note that these functions are periodic, so we can multiply with, we can add where n belongs to, where n is a integer. So let's read this problem. A ladder of 10 feet long rests against the vertical wall. Theta be the angle between, so let theta be the angle, uh, let theta be the angle between the top of the ladder and the wall, and let x be the distance from the bottom of the ladder to the wall. If the bottom of the ladder slides away from the wall, how fast does x changes with respect to theta at theta equals to pi by 3? So first of all, let's draw this scenario. All right. So what is happening? We have we have a 10 feet ladder. So this is, suppose this is your ladder. So let me basically have, so this is our ladder. Okay. Okay. Now, what are the things given to us? Theta be the angle between the top of the ladder and wall. So this is your ladder. This is the wall. And this is the ground, right? Okay. Now, theta be the angle between the top of the ladder. So this top of the ladder is here and the wall. So this is your angle theta. Now, what else is given? X be the distance of bottom of the ladder from the wall. So this distance is going to be x. Yeah. Now, what is the question asking us? How, if the bottom of the ladder slides away from the wall, how fast does x changes with respect to theta? So how does x changes with respect to theta? So we need to basically connect theta and x. We also know that the ladder is 10 feet. So what can we use which will connect theta, x, and 10? So that will be connected by the trigonometric function sine theta, which is opposite side to theta over hypotenuse, which is fixed 10. Okay. So in that case, we get this thing. Now we can write x equals to 10 sine theta. Now we are looking for dx by, so how fast does the x changes with respect to theta? So let's look at dx by d theta. 10 is a constant which comes out. Derivative of sine theta is cosine theta. Yeah. Now we need to plug for the desired value. We are given what? Theta equals to pi by 3. So when theta equals to pi by 3, what do we get? We get, when theta equals to pi by 3, we get dx by d theta equals to 10 cos of pi by 3, which is going to be 10 times cos of pi by 3. So cos of pi by 3 is what? Is 1 over 2. So this is going to be 5. And always remember the units. So what are the units here in this case? So how fast is it changing? So x is measured in what? The length is measured all in feet, and the angles are measured in radians. So we should basically say 5 feet per radian. So therefore, x changes at 5 feet per radian. Does that make sense? Okay. All right. So now let's come back to the derivative. Sorry, the limits. So we know that limit of what? Limit of theta or sine theta over theta as theta goes to 0. All right. This is important that theta is going to 0, not to other values. This is what? This limit is 1. So now what we can do is we can do this problem. Let's try to do this problem then. So limit as theta goes to 0. You can either say sine 2x. So theta over theta. So these angles should be the same. We have only x here. So we'll multiply and what? We'll multiply and divide by 2. So this is going to be 2 times limit as x goes to 0 of sine 2x over 2x. And since these angles are same now, this limit is going to be 2 times 1, which is 2. Okay. Now note that you could have done this in the other way as well. You could have said, well, this is same as limit as theta goes to 0. Now what is sine 2x? You have sine 2x is 2 sine x cos x over x, but I'll give that x here just to this part. And then we get this limit is 2 times 1 times, what is the limit x equals to 0 of cos x is 1. So we get 2. Note that again, this separation works because each of the individual limits exist. Okay. All right. So what about this problem? So what is limit as theta goes to 0 of sine 2 theta over cos theta minus 1? Okay. So let's try to do this.